All right, here are our solutions to perfect problem 7. We're given a 7th degree polynomial. Kind of crazy. And asked to find the 7 roots, basically, is what we're supposed to do. But it gives us some hints here. First, it says, using the first 4 terms as the first group, and the remaining 4 as the other group, factor by grouping. So what I mean is we got 4x to the 7th, plus 12x to the 6th, plus 28x to the 5th, minus 300 x to the 4th. This is my first group. Then my next group will be negative 16x cubed, negative 48x squared, negative 112x, and 1200. And so what it wants me to do is look for the greatest common factor between these 4 terms. They all have an x to the 4th in them, but actually I think they all have a 4 in them also, because all 4 of these coefficients are divisible by 4. So I can factor out 4x to the 4th power, and what I'd be left with is just an x cubed from this term, a 3x squared from this term, 7x from this term, and negative 75, I guess, from this term. And then hopefully, if I'm able to factor by grouping, which I better be able to because that's what it told me to do, there's something I can pull out from each of these terms so that I'd be left with exactly this thing in the parentheses. Well, if I'm going to be left with x cubed, I better be factoring out negative 16. And let's see if that works. If you pull out a negative 16 from negative 16x cubed, you get x cubed. If you pull out a negative 16 from negative 48, you'll be left with a positive number. 48 divided by 16 is just 3. So you get plus 3x squared. 112 divided by 16, well, negative 112 divided by negative 16 is the same as 112 divided by 16, which is just 7. So I get plus 7x here. And then finally, 1200 divided by negative 16 is going to be a negative number. And 1200 divided by 16 is 75. And now we can go back over here and check, make sure we got the same thing in the parentheses. It looks like we do. X to the 3rd, 3x squared, 7x minus 75. Awesome. I got 2 terms, and they both have that big mess in the parentheses in them. So I can factor out that big mess. X cubed plus 3x squared plus 7x minus 75. And if I do that, this is gone, and this is gone. So all I have left is 4x to the 4th minus 16. So my polynomial f of x is equal to this thing. This is a lot better. I'm starting to factor it. What's it want me to do now? One of the factors should be a difference of squares. Ah, interesting. This is a difference of squares here. This is 2x squared minus 4 times 2x squared plus 4. And for the other one, a 3rd degree polynomial. Yep, that looks like a 3rd degree polynomial. All right, now it wants me to express this as a product of 7 linear terms. Got a lot of work to do. But it tells me how to do it. It says use polynomial long division on the 3rd degree polynomial. Okay, so this thing right here, it's saying don't bother trying to factor it. You're going to have to use polynomial long division. So to use polynomial long division, I need one of the roots. You can start just by trying things. But it says to test x equals 3 first. And the way you test x equals 3 is you change all the x's into 3's. So you get 3 cubed plus 3 times 3 squared plus 7 times 3 minus 75. That's what, 27 plus 3 times 9 is also 27. 7 times 3 is 21 minus 75. See, 27 and 27 is 54, plus 21 is 75, minus 75 is 0. Nice. That means is 3 is a root. What else that means is that x minus 3 is a factor of this mess. X minus 3 times something equals this mess. What I have to do is figure out what is that something, and the way I'll do that is with polynomial long division. X minus 3 goes into x cubed plus 3x squared plus 7x minus 75. If I get a remainder, I'll know I did something wrong. Let's see, I want to get rid of this x cubed, maybe in a different color so things don't blend together too much. I put an x squared here. x squared times x minus 3 is x cubed minus 3x squared. And that's good because now when I subtract, this column goes away. This column, be careful, it doesn't go away. 3x squared minus negative 3x squared is the same as 3x squared plus 3x squared, which is 6x squared. If I want to get rid of this 6x squared, I better put a 6x up here, because 6x times x is 6x squared. 6x times negative 3 is negative 18x. Now I subtract again. 7 minus negative 18 is the same as 7 plus 18, which is 25. If I want to get rid of 25x, put a 25 up top here, because 25 times x is, sure enough, 25x. And 25 times negative 3 is negative 75, which is nice because now when I divide, I get a 0, which that won't print out because it's too far down, but I get no remainder. That's a good thing. What that means is that this polynomial is just x minus 3 times x squared plus 6x plus 25. What I've managed to do is factor this polynomial into 4 terms. One of them's linear and the other 3 are quadratic. And actually, well, let's call that good. I think that's as far as you can factor this. But we know that we're trying to find the root, so we're trying to figure out when this thing equals 0. It equals 0 if x minus 3 equals 0, or if x squared plus 6x plus 25 equals 0, or if 2x squared minus 4 equals 0, or finally if 2x squared plus 4 equals 0. This one's easy. Add 3 to both sides, you get x equals 3. This one's a little bit harder. A couple different ways you can do it. One way would be by completing the square. Complete the square, you subtract 25 from both sides, then add 9 to both sides. The reason you added 9 is because half of 6 is 3, and 3 squared is 9. Negative 25 plus 9 is negative 16. And now what I have is a perfect square on the left-hand side. It's x plus 3 squared. So if I take the square root of both sides of the equation, I get x plus 3 is equal to plus or minus the square root of negative 16. In other words, x plus 3 is equal to plus or minus 4i. Therefore, x is equal to negative 3 plus or minus 4i. Over here, I only have the letter x written one time, so I can solve for it. Add 4 to both sides of the equation, and I get 2x squared is equal to 4. Divide both sides by 2, and I get x squared equals 2. Take the square root of both sides, and I get x equals plus or minus the square root of 2. All right, and then over here, again, I only have the letter x written one time, so I can just isolate it. Subtract 4 from both sides. Divide both sides by 2. Take the square root, and I get x equals plus or minus the square root of negative 2. In other words, x is equal to plus or minus the square root of 2i. So what I have are 7 roots here. Here's one of them. Here's the second and the third. Here's the fourth and the fifth. And here's the sixth and the seventh. Make sure I'm doing everything that it was asked. Express the polynomial as a product of 7 linear terms. I can do that. Now that I have the 7 roots, I can express it as a product of 7 linear terms. I can say f of x equals x minus this root times x minus this one of these roots, negative 3 plus 4i, times x minus the other of those roots, negative 3 minus 4i, times one of these roots, x minus the square root of 2, times the other of these roots, x minus negative square root of 2, in other words, x plus root 2, times x minus these two roots, x minus the square root of 2i, and finally x minus negative square root of 2i, which is x plus square root of 2i. 7 terms, 1, 2, 3, 4, 5, 6, 7, all linear that I factor this polynomial into. But there's a problem. If you try multiplying all of these together, if you were to FOIL that all out, I don't recommend you do it, but if you were, you would end up with x to the 7th power, but from multiplying all the x's together. We're supposed to end up with 4x to the 7th power. How can that be? Well, we haven't considered that there could be a number in front of the whole thing. In fact, there would have to be a 4 in front of the entire polynomial. If you left that 4 out, I'm not too concerned with it, but technically to get to that point, we should have been here. If you're wondering where that gets lost, it's kind of in this step here, 2x squared minus 4. When we solved that, we kind of divided both sides by 2, so we lost a 2 there. Same thing over here, we lost a 2 when we divided both sides by 2. So that 2 times this 2 was the 4 that we lost. So there should be a 4 out in front of the whole thing. So really the final answer should be this thing. Although if you didn't put the 4 out in front, I'd be pretty happy anyways. You know, you got most of it right. Really the idea is finding the roots, which are these roots here. I'll call that good.